why the heck did I make you step through a hula hoop and hold hands?
Because we had nothing else to do.
Okay. So let's look at our graph. It's not perfect. Those of you who are perfectionists, it's not perfect, but we have a pattern, don't we?
Yes.
What does the pattern look like?
Up, down, up, up.
Oh, up, just up.
Does it kind of look like a line? Like, it kind of looks like there's slope. I mean, it's not a perfect line, but it's real time data. It's not going to follow an exact pattern. Okay. Don't make eyes with these people.
What are you doing?
Okay, so it kind of looks like a line. If we were to describe the slope, what kind of slope would this line have?
Positive.
It would have positive slope. Okay, so we're going to talk about correlation today. Okay, and what that means. Now, on the back side, I asked you to figure out how long it would take 100 people. What did you guys say?
200 seconds.
Okay, so it kind of seems like we're following a pattern where it takes double the amount of seconds as people. So you said 200 seconds. If we did the whole school of 750 people, you would have said what, 1,500 seconds?
Yeah.
Is that what you said? Okay. Go ahead and in your notes, let's turn
Have we ever been in this photo?
to page 24.
All the way back there. Oh my
Big jump.
gosh.
It's not a big jump. It's one page from where we left off.
It felt like that. It's been like a long.
Okay,
Today's Thursday. Or Wednesday.
it is definitely Wednesday. Okay, so what is a scatter plot? Okay, a scatter plot is a graph. That shows the relationship between two sets of data. Okay, yesterday we collected data of number of people and how long the hula hoop took. We plotted those on a graph, and that was a scatter plot.
Squidward?
Yeah.
Actually, what?
I was
Okay, so you said that, I'll come back. In our data set from yesterday, it sort of looks like there is a linear relationship. It trends like a line. It's not perfect. If you're a perfectionist, I'm sorry, but it trends like a line. And you said it looked like it would be a line with positive slope. Okay, so when we get a scatter plot that has a positive, we call it correlation, then it's going to look like this. We're going to have the X and Y axis, and we're going to have a bunch of dots that look like they are aligned with positive slope. Bella.
Draw that.
Yes, I want you to draw this where it says positive. Braylee, I need you to draw this. Okay. But she is. Yeah.
You have to do 2 lines or?
Oh my god. This dog's gonna go.
Chill.
Take your own advice, buddy.
What?
That was scary.
Okay, what's it gonna look like if we have a negative correlation?
It's gonna go this, the Y is gonna be up. Never mind.
Like this. So it's trending like a line. It's not perfect, but it's trending like a line with negative slope. No, and the whole point is that data is not going to be perfect. Okay. When we record real time data, it is not going to be perfect. It's going to have a trend, maybe, but it's not going to be perfect. Okay. Now, if there's no correlation, I think you guys are really going to enjoy drawing this.
Are we? It's gonna be fun.
What are you doing?
Stop. If there's no correlation, then it does not look like a line.
Oh, that's cool.
This kind of reminds me of science.
It should remind you a little bit of science.
Remember, because like it would go great on when it stops.
Bad, of course.
I don't know. One of them.
I don't know.
Okay, so I want you to think about these three things here. Okay. The size of a house versus the size of lot. When I say lot, like what it's on.
On the grass, the mud.
Okay. The number of passengers on a plane versus the number of suitcases.
Oh, more suitcases.
The number of days into fall versus the number of leaves on the tree.
The number.
No, I'm just saying, I want you to think about this. Okay, so let's start with number 3. The number of days into fall versus the number of leaves on the trees. What's happening to the leaves as we go further into fall? Okay, because they fall. Okay, so the more days we're into it, the less leaves we have on the tree.
What?
The more days into fall,
Okay.
the fewer leaves we have on the tree.
Yeah.
So what kind of correlation would that be? It would be a negative relationship because our leaves are falling. Don't feed into her craziness.
I think we need to separate these.
Already separate.
Make sure they can see each other.
Okay, what about the number of passengers on a plane versus the number of suitcases?
It would be.
I think it would be kind of even.
It would.
The same.
No, it'd be more.
Okay, so the more people, the more suitcases. So that would be a positive relationship. What about the size of home versus the size of the lot?
More lot than the home.
No.
Wait,
Would
what?
be the same.
No,
The home is in
the
the
home-
lot.
What about those farmhouses?
What part?
The home is in the lot.
It'd be
Miss Holman, you made that.
opposite. What?
Wait, is it the lot? The home? Yeah,
The lot's like the
home.
land.
Why are you saying that? Yes.
What?
So the size of the lot doesn't necessarily depend on the size of the house because me and Corin could have the same size of house, but maybe I live on an acre and she lives in the middle of Papillion where her neighbor is like this close.
That would be me.
Okay.
JJ's my neighbor. Yes, she is. I can walk. Okay. I live right here.
All right, so the big part of today is being able to make a scatter plot and then read it, okay? So here I have a set of data, hours and grade, the number of hours a student studied for a test and what their grade was. Just prediction, do you think there's gonna be a relationship?
No.
You don't think so?
Actually, wait.
There might be.
They went from 5 hours. It depends.
Okay. So here are like 10 students. They reported this is how long I studied, and here are their grades. So do you see how they're organized in this chart? This is going to be our X and this is going to be our Y. So down here on the X axis, I'm going to write hours. And over here on the Y axis, I'm going to write grade. Okay. So it looks like we have hours studied anywhere from 1 to 8. So let's just 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 45 all the way to 100. So let's do this little cute little.
Yeah, I knew it.
Okay, and what I'm gonna do, I'm gonna count by fives, but I'm gonna start like right here on this second one at 50, and then 60, 70, 80, 90, 100. So it looks like this. This is what I want yours to look like.
Oh, like that.
You skip a line.
And you know what? If you don't, it's fine. If you went 50, 60, 70, 80 without skipping a line, it's fine.
I missed mine. How'd you miss mine?
Because counting's hard.
It is.
Yeah.
I agree.
Okay, so this is what we need to do. This is, honestly, we've done the hard part. Which I know, right? Now I need to plot these. So 380, I'm gonna go to 380.
That's good.
Oh my God. I dropped it on the-
590. Okay, so you plot these along with me. 245. It's not going to, buddy.
Yeah, buddy. Yeah, buddy.
Oh. What?
Yeah, the institute.
Okay, because there's 2 different people who studied for 2 hours, but they got different grades. Ray, do you need to go on a walk? Okay.
It looks like a line to me.
Okay, does it look linear-ish?
Sure.
Okay, it looks line-ish and it's trending with what kind of slope? Okay, so we are going to say that this has a positive relationship. The longer you study, the higher your score, is what this data set is showing. Okay.
We say 7 hours, got 100. So the person who stayed for 8 hours only got 95.
So they're not-
Technically.
Yeah.
That person pays more.
We're not done, but yes, that's fine. All right, let's look at number 5. The number of hours a person spent in the mall and the amount of money they spent. What do you think could happen? the amount of time they're at the mall,
More hours.
and how much they spent.
I think the more.
The
shorter you're there, the more money you spend.
No, the
What?
longer you're there.
Well, she said it's 8 hours. Spent 150.
Well, okay, so, okay.
It depends on who you are.
Okay, so maybe this could be interesting. So here's our X, here's our Y. All right. So we're gonna label hours down here, hours at the mall versus dollars. Money, money, money. Okay, so let's look at our hours. It looks like we have anywhere from 1 to 8 again. 1 through 9? Oh, thank you. And then dollars, anywhere from 15 to 115. So let's just count by tens. And we can start at like 0, 10, 20, 30. And let's just not forget that 90 exists. Okay, if I didn't tease you, I wouldn't have done my job, Jada. That's true.
No.
You can graph it now, yeah.
Oh, this is a hard part.
Oh, so hard.
So like when I graph 825, I'm just gonna come in the middle of 20 and 30 to graph that point.
Sorry, I tried to. But.
You guys get apples?
Just don't look.
Oh, Brady, we have a new student calculus class.
You guys?
Oh, yeah, in the period. I forgot that you're not in a period. Oh my God.
Don't just.
Yeah.
Okay, look at your data. Does it look line-ish?
Oh,
Oh my goodness, it is all over the place. Okay, maybe there are some people who like to just be at the mall and walk around and window shop. Window shop, they just look in the windows but don't buy anything. I can see how that could be a mistake. Okay, or maybe you know exactly what you want. You go into the mall, you spend a lot of money, and you're out. Okay, there's no relationship. Okay. All right, so let's go to the next page.
Oh, what?
The next page. I want to look at number 8 and number 9. Okay. So in number 8, it is showing a company's stock price since it was launched. So down here you see the year, and over here on the y-axis it's the dollars per share. It's the stock price. Okay. So in 2015, what is the stock price? All right, we need to read this graph. So I need to come down here. 2015. What do you think? That's right here? So here is the dot right here. Look at me. Here's the dot.
I said 22.
Okay, you know what? I would accept either one. Okay. So about, you guys want to say? About 22, about 21, I would accept either of those. Okay. I was hearing a lot of 22s and a lot of 21s.
It's below.
Okay. Now, what about this one? In what year was the stock price 35? Well, now we have to go over to the y-axis. Here's 35. Ooh, it happens twice. It happens in 2010 and in 2012. What's the relationship? They're going downhill, which means we have a negative. Okay. And if this is true, we can follow the trend to figure out what's going to happen in years to come. And that's something we're going to do tomorrow. Based on this trend, they're in trouble. This company is in trouble.
They were doing so good.
Okay. Okay.
They were doing
Now,
so good.
I think Ryan. I don't know why, because we're talking about Olivia buying a car in April. I don't think it's this Olivia. Olivia, did you buy a car?
I didn't know.
Yeah.
They bought a car.
Okay. The graph shows. You know what this is?
Odometer.
You know what that is?
Meter, odometer.
I don't know.
How
The
many
middle.
miles it has.
Oh,
I know that.
Each month after she bought the car. So here's the months and here's in thousands of miles. Okay, so 4 means 4,000 miles. Okay. So how many miles were on the car when she bought it?
3,000. Nope, 3,000.
I would say about 3,000. Because it looks like they're counting by twos. This is in between 2 and 4. So about 3,000. Okay. Approximately how many miles were on the car in July? She bought it. You know what? I made this mistake when I made my answer key. So this is April, June, May, June, July.
whoa, wait.
She bought it in April. So 1 month later is May, and another month later is June, and another month later is July.
6.
Oh, this is way too.
6, 7.
About.
I would say 7,000. In what month did the car reach 14,000 miles? Well, here's 14 right here. April, May, June, July, August, September, October, November, December.
Wait, when did you buy it?
Wait, our 0 is. No, Miss January.
Our 0 is April.
Oh,
Okay.
because we started.
Okay. I want you to turn to page 28.
That's one.
Oh, my. Oh, wow. Is that homework?
Oh my gosh, we're almost done with this. Do you have a CSA coming up?
When's our last CSA?
Wait, how many more?
Okay. I want you to
28.
I want you to label your graphs like I did up here so that you don't have to like worry about how to label your X and Y axes. Okay. All of page 28 is your homework, but cross out number 4. Okay. But I want to give you an opportunity to at least label your graphs so that it can help you. So this is 1 through 12. And then this is a squiggle. And then I start 50, 60, 70, 80, just like we did in our first example. Over here, I squiggle and I count 100 and then by tens. Here's a squiggle, I count, this is 300 and I count by 50s.